As with all Windows artifacts, it just seems like the hits keep coming. We hang our hats on particular artifacts as incident responders, investigators, forensics, whether you're doing criminal investigations, employee investigations, and these artifacts change quite frequently. So we were talking right before we got started here about being a lifelong learner. You just have to be, if you're working in this space, constantly changing environment with the operating systems that are constantly in flux. I say constantly just because time passes so quickly. It might be the same month on month, but year on year, definitely not. So we're going to be talking about an artifact that's really exciting to me. And I have to say, it's really exciting to a lot of people. We're going to give shout outs to other researchers who are in this space that have done a bang up job of really getting education out there for what the Windows Search Index is, how it can be used. And I have tons of references in the back end as well. So if you want to watch more YouTube videos about this artifact, consider other use cases. There's a ton of information out there, but mine will be different because it's Valentine's Day and we're talking about For the Love of the Windows Search Index. I actually I love discussing process, because I've spent so much time looking at the contents of memory images. So we're going to be taking a different slant. Of course, we're going to cover the tools that allow us to parse and tear into this Windows artifact. But I really want to spend some time educating everyone about the indexing service. Like that is the most boring thing ever. Or maybe you think the indexing service is your enemy because on earlier versions of Windows, it just didn't stop, you know what I'm saying? It didn't back off. So it was like a resource hog. Even today, you might look up a Windows 11 search indexer and people are like, you can just turn that sucker off because it does consume resources. But things are better now. Let me explain what Windows Search and this indexing service, as it used to be called in early days, what is it? Well, it is one of those user experience enhancements. It's all about improving the user experience. You know this because all of us at some point in time have been a Windows user. You may deny it, but I know you've been behind the keyboard on a Windows machine before. So with the Windows Search Index, it really does in the backgrounds get ready, constantly getting ready for that user sitting in front of the keyboard, lodging a question against, probably in the confines of your Windows Explorer, now known as a file explorer. You have a search box. You can type in there. You can drop down advanced search features, capabilities. But the indexing needs to be done ahead of time for that lightning fast response. So it's not going to be everything by default that's indexed. We're going to talk about the scope. That is the default scope, what the indexing service is seeking to do for you, and how you can kind of modify its behavior. And then we'll get into parsing it and looking for maybe some relevant artifacts, some additions to your timeline for your investigation. But hey, I want to make mention of this fact that the whole format of this database has shifted as we move from an ESE database. That's my extensible search engine format that Microsoft loves or used to love and show great passion for, including everywhere throughout the OS. But now we see a pivot to SQLite backend. So it's a SQLite database now in Windows 11, and that's a little bit later versions of Windows 11, you're going to see the SQLite database format. So we'll talk about that. Kind of one central database has split into 3 right now. So yeah, as you move from Windows 10 to Windows 11, there's a difference in how you have to approach parsing this data set. And you might be wondering, like, how does the magic happen? How does the search indexer know that it needs to revisit a directory, that files have changed, Well, it's tracking and using entries in the USN Journal. So the USN Journal responsible for tracking the changes in file accesses that are happening on a volume. So like, hey, the search indexing is like, hey, the USN Journal, what's happened? So, what files have changed since I last crawled the directories? And so, well, that answers some of my questions, remove some of the mystique and mystery around this, but we know that the indexer does run as a system service. So that kind of comes into play when we talk about some of the attacks that have been performed against this this service. I think it's just masterful. Any adversary who's out there that's thinking, oh, I can go in and parse the search index of my victim machine. But more on that. I want to talk to you about the evolution of the indexing service. Back in the day, it all started with just indexing the contents of IIS, so inet pub, that directory. Windows 2000, we saw that this was a feature that could be added on, not enabled by default. Windows XP, you can see the names change. The naming convention shifts across different versions of Windows. It reminds me of the Metro Tile apps, Universal Windows apps, now just Windows apps. But yeah, it's like you got to keep up with the naming conventions. And so for XP, the search indexing capability was named Windows Desktop Search. My favorite time really in the evolution of Windows Search was the introduction of Windows 7. And Zach was asking me, how did you get your start in teaching, Alissa? Well, I remember teaching Intro to Windows 7, forensic artifacts of Windows 7 at the Guidance Software CIC conference. Woo! But one of the things I thought that was the coolest ever was that advanced search bar that was introduced with Windows 7. And you had an opportunity, really got that insight into the granularity of what's being tracked on a Windows system. Like, your sticky notes, I can search for the color blue sticky note, and the contents. And that's really when the search indexer started to explode and go in and really grab granular details. More on that. But Windows 10 will feel more comfortable calling this capability the search indexer on Windows 10. They're going to hear all kinds of things. But with Windows 10, 2 new features were introduced, and that was the ability to add some exclusions. Like, hey, do not crawl these directories, even though they may be subsets or subfolders in other folders that I've said to crawl. Now we can put in excluded folders, excluded files. The other one is the enhanced search options. So it got even more granular, catering to user needs. I'd say, optimized search much faster and not as annoying because it backs off, does a lot of its crawling through directories when the system is idle. And you can control some of that. That's the good thing. All right, so as we pivot into conversations about why you care, if you are working in security operations, this becomes yet another artifact that you can pull from a remote system that will allow you to augment your timeline. So not only am I able to get decent visibility as the contents of directories, but I can go in and search for file types. I can search for keywords that are located in files and come away with some insights into the auto summary that's saved. So all of these things in this list are going to be quite valuable. I'm going to point out some of these columns that are going to show up in our database, whether it be the ESE database or the SQLite database. But what I find most interesting is the whole searching through a OneNote, really being able to, where did I save that? Where did I save that config? The ability to search through and include the contents of OneNote, include the contents of Outlook, PST, and you can see activity history here. That makes reference to the activities cache database and the contents that you would find in the activities cache database, and that's per user profile. So really good stuff here. And hopefully it's not making you worry, but you should be getting really excited about this stuff. Now, you're like, well, if I have the entire remote system to access, to ask questions against, and pull back additional data, why then would I want something that's akin to the $MFT? Like, hey, I already have the ability to enumerate the metadata associated with files. Well, the MFT is not going to share with you an auto summary. It's not going to share with you the actual more granular metadata from files. So there truly is a value as you look at these two. Say artifacts of gold, the $MFT is pretty slimmed down when you compare it to the data that you can drive out of the search index. Of course, nothing beats having the actual files in front of you, but if you don't have the files, say that system was pulled offline and you have to answer questions with what your triage data can provide to you, then this is definitely one of the locations that you want to parse and pull these details into your timeline. So I think it will really help in the absence of being able to walk a directory structure yourself. So what am I excited about? Well, I used to think that the Windows search index did the entirety of, say, your NTFS volume, your C drive. It is not the case. By default, it's pretty limited in what's being indexed or crawled. We have the contents of the users folders, that's all of the user profiles, and then the start menu, but not just any start menu. It's the start menu that's located in the program data, more of that default start menu that impacts all users. So yeah, I think that's pretty good. I'll show you some screenshots of some of the contents, but don't think you're stuck with this. I was actually looking at an enterprise system, so very much subjected to group policy. And this is one of the things that you can, in fact, configure in your enterprise as to what is being indexed. Yeah, I guess you could say that the options are limitless. You really could index everything for everyone in your enterprise, all Windows systems, but it is going to be, what is this? Say, maybe there's some overhead that you want to consider, and maybe you don't want everything indexed, especially maybe sensitive folders and the contents therein. So I'm just showing you screenshots of the defaults. And then you can go in and further expand because, say, the app data is actually deselected in each of these user profiles. App data is not indexed. What I saw where the directories were, but the contents of those directories not indexed. So yeah, again, I'm going to show you some screenshots. By default, encrypted files not included. Being able to crawl through those encrypted files. It is something that you can enable, but then you have to contend with what type of encryption. So as I customize this, I did make mention of, I am well aware that enterprise environments may deviate specifically, from this default. It's all about defining the scope of what your search index is going to be crawling. So big word, but the scope is important. And, there is some magic behind this, and that's why it's perfect to talk about on Valentine's Day. There are two types of handlers that really facilitate search indexing. There's the protocol handlers, and then over there, we're really going to explode this topic, the property handlers. So the protocol handlers are like, how does the search indexer gain access to the data that it's going to be crawling through? So I have a couple examples there. Gaining access to stream-based data that is owned by Outlook actually requires its own protocol handler. SharePoint, same. Like, how is that access to the data derived? Search-MS, URI, protocol handler. So you're hearing protocol handler, all of these are facilitating access for the Windows search indexer. But over there, the other type of handlers, property handlers. So everyone knows there are different file types. They have different formats, and based on the formats of the particular file type, you're going to have different metadata exposed, different metadata that you can access. So how does the Windows search index know what metadata is available per file type? It is through the definition of schema, the definition provided, I guess we can call it an I filter. These are property handlers. So they tell the Windows search index like how to extract metadata from a particular file type. So yeah, it is pretty fascinating. And if you go into search indexing on your Windows machine, control panel, say, dialog box will pop up and you choose indexing or customize indexing. Advanced options is where you're going to see the screenshot that I have over here on the left. These are going to be unique. They're very specific to the extension. It is a Windows machine. So it's all about the extension and the associated filter for the interpretation of those file types. You'll see also there's an option here. Are we going to index the metadata or the properties of these files, or is it going to be properties and file contents? Oh, yeah. So the surprising part to me was, as a developer, I can introduce and register new iFilters. So I can actually introduce new file types, or these property handlers. And I'm answering the question, I'm providing the information for the indexer to then go in and pull metadata and include it in the index. Not only can, say, third-party developers register one of these property handlers, but they can also, obviously, they can also make calls to and access the contents of the search indexer. So again, kind of blew my mind that I'm like, this is open to everyone? Are you serious right now? But sure enough. So I got your definition for you of the I filters. Anything else that I need to speak to? Yeah, I definitely made mention of that whole third-party developer capability. Microsoft has some really good documentation online for how you too can develop a property handler and register a property handler. But I have been looking at search indexer processes for a super long time. Just like, that's normal, that's normal, that's normal. I know it came in groups of threes, but I actually set out when I was crafting this presentation to provide definitions of these three processes associated with the Windows search index. Woo, let's go into it. You've probably seen these too. I'll go ahead and provide a bit of an overview of each of these processes. So the search indexer responsible for, well, writing to the index. You would also, like if a third-party application wanted to make or access the Windows, we'll say .edb, this process is what's going to expose or handle API calls that will allow third parties to make access to this database. So that's the search indexer. Finally, someone defines it for me. All right, search protocol host. Protocol points back to protocol handlers. So this process is responsible for providing that access, accessing the individual handlers and providing access to the data store or data store type that the search indexer is going to be crawling. And then over there, it all makes sense now. Look at that process name, search filter host. And we just talked ad nauseum about the I filters. Remember, property handlers. So that's what search filter host is going to be all about. Host the I filters and property handlers to extract the metadata. Yeah, it's a low integrity process. I was pretty impressed with the fact that these running processes, albeit associated with a system service, they do make an effort to run at the lowest privilege level. So maybe I'm running a system on my local host, but if I am crawling against, say, a network share, it's going to be using the permissions that I have as a user. So, which is better than, going and running a system on that remote device, I guess. So hopefully this sheds light on those three processes. Totally benign, totally legit, except for if we're dealing with like a malware like Pickabot. Pickabot, I think it's the search protocol host, goes ahead and spins up an additional search protocol host process in a suspended state, hollows it out, and stuffs the evil malicious code back into the context of that process for execution. So I say, never take anything I say as 100% all the time. It's a rule you'll never see deviated from. No. I'm saying you should see the three of these on a normal uncompromised Windows device, but it doesn't necessarily mean that the processes themselves are not susceptible to compromise. Certainly not, as I just made mention of. And you see quite frequently these legitimate Windows processes, trusted Windows processes, being hollowed out or injected with malicious code. So, I cannot guarantee the integrity of your search index processes, but I can at least inform you of what they're supposed to do normally. All right, so let's talk about where this database and all of this information that is being picked up when the service crawls through the directories, where does it reside? We're going to talk about two different OSs, Windows 10 and Windows 11. Thank goodness the location of these databases remains the same. I can remember that. Okay, program data. I've been known to say there's nothing to be trusted in the program data directory. I've taken it back, but very early days, I was always pretty suspicious of program data because it does seem to be one of the favorite locations for malware, rogue installation of crazy Trojans. Trojanized applications. That's what I say. So I'm telling you or sharing with you yet another gem that's in program data, and I'm really backpedaling here. We're going to go Microsoft Search Data, Applications, and then Windows. I totally was running through this several times over before the webcast, and I got these inverted all over the place because rarely do you find a directory path that's quite that long. But if you see here, the windows.edb is going to be the primary for Windows 10. You guys might be balking, like, I don't use Windows 10 anymore. Who uses Windows 10? A good number of people. So we're gonna talk about Windows 10, and no, we're not going to find the search index populating, running as a service by default on your servers. So I really am talking about my workstation versions of Windows. So we're going to start off talking about Windows 10. Let's do it. So we have one ESE database, extensible storage engine database to parse. And I tell you what, it is a hot mess in there. You'll see what I mean. There's just so much data. I'm showing you just enumeration of three tables that you're going to find in the windows.edb. The one I was looking at right before joining had these number of columns. So I got the system index gather table with 20 columns, the gather path with 3 columns, and the property store, which I got pretty excited about because, again, this is all falling in line for me, that I have 598 columns. These are specific to the attributes of the metadata from the file types that are being crawled. You take a look at some of these column headers that are in this particular table, the property store table, and you really get a feel for, like, hey, contact information. Those columns are largely empty unless we're parsing through contacts. And then it's valuable. So that's what I mean, that the windows.edb there's a lot going on in there. A lot of it, particularly in the property store table, is going to be empty unless that particular attribute, metadata column, pertains to, say, the file and the file type that was crawled. All right, so that was 598 columns for me. But if I was making use of some of that third-party software where part of the installation was to register particular file types, register those I filters, I very well I'm going to have more than 598 columns. Actually, I pulled the windows.edb from an old VM that I used in one of my classes. So don't think there was too much custom software installation. So your numbers are going to vary. I'd be interested to see just how crazy it can get in there. But I want to show you a few tools. Of course, we're going to talk about Cider, which is the newer tool from Strauss Friedberg. Thanks, Strauss Friedberg. But let's talk about some of the other ones first, the ESE database view. Maybe that's, I was using this first, and maybe that's why it seems so complicated. But this is simply going in and showing you the structure of the ESE database with all of its tables. Yeah, you can flip through, drop down, move, look at this table. I'm just showing you a very clean screenshot. I know what you're saying. Like, why does she think this is busy? Well, I'm just showing you one of those 500 plus columns. And it's the one that means the most to me right now, because again, the mystery was why program data, Microsoft Windows start menu program, like why that start menu? I get it. It pertains to everybody who logs on, and you can see here, I have my LNK files tucked down here. Anyways, scroll through the rest of this output and you're going to see all kinds of other information. But I left this as default. You're going to see that I just have indexed directories and files that were located in the users, profiles, and what you're seeing here, the start menu of the program data. I want to point to, and we'll see this again a little bit later with the output of another tool, but I want to point to this particular header or row identifier. It's a type or a category type of entry in my windows.edb, this particular table. This WinRT refers to the Windows runtime. So it gets pretty convoluted, but I want to point you back to that activities tracker, the activities cache.db. Yeah, the one that's associated with the Windows 10 timeline, no longer called timeline, but that tracks what users do in the context of their user profile as they're logged into a machine and they're hooking and jabbing using all of these applications, programs, and whatnot. Your WinRT are going to point to those particular captures. So you can see, maybe you recognize it, maybe it all looks like an enter ID to you, but this is actually the user SID, and you're going to see that WinRT is followed by the user SID, and then you have some specific activity capture that's associated with what that user profile did. So I just wanted to point out that that is in fact different from the rest of our lines that you see preceded with file. And you'll actually see those being output in a separate parsed CSV or JSON file when we get to some of these more sophisticated tools. Oh, there you go. Let's talk about Cider from Strauss Friedberg. I will again say, this is amazing. Thank you, thank you. Obviously, with that last tool from Nearsoft, it doesn't support going in there and looking at these Windows 11 search index databases, because Windows 11, SQLite, sure, I could use a SQLite manager. Thank you very much, but it's not my favorite tool. So I'm so glad that Cider rolled out last year when Strauss Friedberg Aon put out their blog post. Again, links down here at the bottom of the slide to where you can download Cider too. wouldn't want to be the only one. But at the end of this deck, you'll see a little shout out to their blog and one of their YouTube videos, as Julie and Falcon have been really hitting the industry or the conference. What is it called? Trail? Yeah, the conferences speaking about the Windows search index and how they were able to gain mastery of it with the use of this tool. So I'm going to talk to you a little bit about this tool. I'm going to use it to parse the EDB a few times over. One of the gotchas, I know these folks didn't know there was gotchas, but one of the things that it clearly says to do here is to point to the directory that contains your windows.edb. I tried the first few hundred times I tried to run this. I tried to point because I see the -F and I'm like, oh, I'm going to point to the file. No, the -F is pointing to the directory where your files are located. And so in this case, I pointed to the desktop, my desktop, because I had output the windows.edb file to my desktop. So you can see a little convoluted. I had some options. I could have outputted to CSV or JSON, but because, as you all can probably guess, I'm in love with the Timeline Explorer. It's part of the easy tools from Eric Zimmerman. So CSV all the way. And I'll show you the output of me running it correctly. Wow, I wasn't lying here. I pointed to the desktop. Ooh, the -F does in fact speak to format. I chose CSV and my output directory. You know, I got some positive confirmation that this parser actually did the job. It created 3 outputs, and yeah, this was today. Created 3 output files, categorizing the entries. And from the very table we were just looking at, the property store. So we have a file report, the internet history, and the activity history. So on the Windows 10 machine that I pulled my windows.edb from, I didn't have any activity cache enabled. Didn't have anything to parse. So that file ended up being 0 bytes and 0 cents. So I'll show you the output from the file report and the internet history. But I mean, this one was super fast. The other tool I'll show you was a little slower. And the other tool does not support Windows 11 SQLite database either. So yeah, I did say this was one of the machines. I extracted the windows.edb from one of the Windows 10 machines that I used to use in my classes. You can see here, wait, IE history is like a new tag that we didn't see in the preview, as shown in the ESE database view. But I can see IE history here, and there is the GUID that represents my user's SID and the URLs. Some of these URLs are local file access. But if you've been in the game a little while, you know that's how MS Edge, Internet Explorer tracks local file access. Yeah. So we're able to not only derive website URLs that I visited. Are there a couple there? Yeah, there are a couple there. But you're also able to see local file access and the full path of where those files are located, because we're parsing entries in that windows.edb that speak to Internet Explorer or MS Edge search history. Good stuff. Good stuff. And this is the file report. So I think it had 1,009 lines in it, but yours will be more, most definitely. Again, this was from a test VM. So showing you the first, 22 lines of the file report that was created with Cider. Thumbs up. Yeah, anything to note here? I guess when we see whack whack, we know that that in fact is speaking to Windows runtime or another tag, not necessarily a file entry in the that had been indexed by the Windows search indexing service. So a little bit of a different category there. Cool. All right. I was saying, like, are a ton. As I'm looking at the file report, I only showed you this screenshot, which was, yeah, like the computer name, the work ID, and the path, the full path of the files that were indexed. Okay, some of these are directories too, but nevertheless, full path of the item that was indexed. But there are other more, you might say, equally of the same value, equally important file columns that you're going to see in this file report output. Some of the cool stuff here is the date modified, date created, date accessed. A grab of, and this is different from the gather time. Gather time is when this item was most recently updated. You know, like, hey, when did that crawl happen most recently of the contents of that directory, this particular file's metadata? So that will allow you to tie back at what point in time am I seeing a capture of the time and date stamps associated with the directory, the time and date stamps associated with that target file. We have the file owner, system size, and item type, which was huge because, hey, you have to kind of be able to eyeball something to tell whether it's a directory or whether it was a file item in a directory. Well, with the item type column, you don't have to guess, and that was excellent to see. Auto summary is probably the most impressive, and I'm going to show you a pretty good use case as to how you may be able to fold the contents of auto summary into your investigations. There are only particular file types where the search indexer goes in and takes the time, makes the effort to dig in to the contents of files. So can you modify this? I think that is a customizable option, but to an extent, you're going to run out of that runway of file type, say, schemas or definitions. So I may not be able to do an auto summary of the contents of a file simply because the I filter doesn't allow me to get a beat on the body of the file versus the metadata. So interesting, the file report is definitely a slimmed down version of all of those different columns that you saw in the ESE database view from the property store table. Wow. I don't know if I could handle the output. Well, I know I can't handle the output because I was getting a little queasy looking at this table and all of its tremendous amount of details in that other tool. So much simpler in its presentation for your CIDR output. Thumbs up. All right, here's a good example of something that was on my Windows 10 machine. And it was just an auto summary being created for a file that was on my desktop. Yeah, I'm trying to remember. What is this? It's like hack all the things, exploit all the things. This was a tool that described different techniques and how you could inject into running processes. Pretty cool stuff, I think. But the fact that I can see, and this actually scrolls down and I can see all of the techniques that are being described in this .h file, it leaves nothing to the imagination, right? Like I got everything and the structure in which it's going to be say implementing the injection technique. So yeah, lots of use cases for this. You're probably wondering, does the file still have to be in the file system? Does it still have to be allocated for me to be able to derive this information? Or can I be asking questions against the windows.edb for files that I know were recently deleted? Now, it's all about, because this is pretty volatile, right? If I have an attacker on my box, he decides to delete the malware, delete the contents of, say, his host-based recon, all of those little text files or the DAT files. If he goes in and deletes those items from said directory, those changes will be maintained in, we'll say, a log file, not immediately updated to the database itself. And so there is say, a time frame where you could call it just the opportunity that exists for that moment in time. Before the sync actually happens and the changes are made to your windows.edb, we can go in and we can recover those particular files and the metadata associated with those files that have been targeted for termination. Oh, one of my favorite movies, Terminator. Such a love story. It's such a love story, Terminator. But so there is an opportunity for you to go in and kind of jump in before the syncing, the actual deleting or unallocating of these entries. But I will throw in there also that we've seen in almost every database that we have found with viable forensic significance, we've seen that there is a lag time, that there are some opportunities to extract unallocated database entries, so unallocated entries from our favorite tables in the windows.edb. It is possible. The next tool I'm going to show you has a visible option for that. I think it calls it orphans. Things that it can't map back to parent directories, but the metadata may still be there and can be recovered. So all is not lost, but I guess I could say all could be lost if you don't act soon enough. If you don't get in there and grab the windows.edb soon enough, those most recent changes will sync in due time. And as more churn transpires, the opportunity to recover deleted entries will be diminished. Yeah, how did I do? So I will say that app data, the contents of app data from my own research, it doesn't get indexed because, well, there's a lot of crap in there, right? I mean, probably a lot of malware too. We are talking about my machine and app data being just prime real estate for adversaries to write to locations on the file system that don't require, say, privilege, like a higher privilege. But app data, the bad or downside is by default, we don't have the indexer crawling through the contents. What I did find though, was all of the directories were present in and this is Windows 10, all of the directories in app data had in fact been indexed, just none of the contents. So I know a lot of research out there says nothing from app data, but I was delighted. What do you say? I was so happy to see more data rather than less data. And again, this being straight from one of my old VMs, figured it would have some crazy in it. All right, enter to the scene, tool number 3. This one does not proclaim to have support tucked into this GUI tool for the SQLite database for Windows 11, but it does a bang up job of parsing your windows.edb from a Windows 10 machine. This is WinEDB browser, and you too can download it from that GitHub link. I found this to provide insights that I really wasn't seeing. I mean, it's probably some of that schema and some of the metadata of windows.edb straight away. I totally can find this myself with my XF tool against the windows.edb. But Cider doesn't present this information to me, or at least not that I recognized. So I kind of like that. I parsed the same windows.edb as you saw the output over there using this Cider tool, but this has some details about the database itself, the size, and you can blow all of this stuff up to look at the raw data, to look at the schema of how the windows.edb is laid out. But you want that clean presentation that Cider gave you, you can pivot over to these subdirectories in entries. So much like the file report, much like the internet activity report that we got. And there was, if you remember, that third report that I didn't find anything populating. That was the activity report. Here, it's called the WinRT, so Windows Runtime. I think I showed you an example of that earlier. So it tells me how long it took to parse and it exported all those tables as a CSV. I found this one to be pretty clean. Oh, I'm pointing out the orphans as well. So my opportunity to maybe claw back some of my deleted entries that are just hanging out, thinking that they're orphans, so I might not have that opportunity for parent-child reconstruction, but there might be something there of value. So I opened up the WinRT folder here and rolling down, I saw, hey, there is my user SID again. And some subdirectories here take me to the Spartan history. So the Spartan history, obviously, it has its own format. It is the web history from me browsing and engaging files from the Edge, so my Edge browser. The cool part is I had forgotten that I'd done this. You see the work ID there. That's going to allow us to jump from one table to another. But most notable here is the title. And I'm like, no way, I looked up dual core lyrics. And I bet that was a good time. And it shows where the target URL is, here, that website. So like, that's pretty nice. I wasn't able to, maybe I failed at running Cider, but for some reason Cider didn't parse any activity history for me. That's what we're seeing right here is the activity history. So I'm gonna bounce back, kick it a couple more times, kick the tires a couple more times and see whether there was an epic fail on my end, or maybe, you know, that aspect of my windows.edb was flawed in some regard. So one tool, but if you were to click through all of these, you're going to see that there are a ton of URLs. So, you know, it really is quite comprehensive with time and date stamps as promised. And that's when this entry in the search index was most recently updated. So I got my gather time there. So let's talk about Windows 11. We're doing pretty good with time. I see it. So Windows 11 is going to maintain 3 different SQLite databases. We get into the bottom of the slide. We talked about the relationship that exists between the USN journal and the search indexer. You know, the search indexer is like, hey, what's going on? What changes have transpired, USN? And so most likely that's what we're going to see here is an element of conversion. You could see that each of my, if I go back and point out the work ID again, you know, the unique key that allows us to pivot and reference the same bit of information across tables, that very well could be what we're going to find in this Windows USN DB, is that opportunity to pivot from that which is being mentioned by a sequence number to, you know, how that parlays into a work ID or the key as tracking that particular item in the Windows search indexer. So we got 2 tables that need to be spoken about. The meat, though, what you're going to see, the good stuff, is going to be in this windows.db. The Windows gather just kind of allows us to make sense of everything, allows us to tie in main or full file paths and map these file paths back to this particular index. This is the index table that I'm talking about, the property store, which you're going to see hangs out in windows.db. Totally makes sense to me. So Cider allows us to parse this windows.db, or you could totally open it up with your SQLite manager. Good luck to you. Good luck to you. But this was actually shout outs to DFIR Report, the DFIR Report team. I parsed some of their data set here from a machine that had been the victim of, let's see, REvil ransomware. So this is the ICE ID and encrypted files. So my Faho readme.txt were created all at the same time. I see just the beginnings of some of the additional columns that you're going to see in your output of your file report output. I just see the access time. We know that will be followed by modified and created. But full path to disk is, and I'm always celebrating. I'm always celebrating when that transpires. And it's not just local. We're going to see that in say network shares, there is that same opportunity for indexing the contents of network shares. I don't have any examples here. No, certainly do not. So this is my use case. I was forced to watch both Top Gun movies recently, like within the last month. And I enjoyed them. There's all kinds of drinking games that you can play when you're watching those Top Gun movies. But we know in the second Top Gun movie, it's like the maneuvers that this team has to make, flying real low to evade, the air defense systems, the radar, and they pretty much almost all die at some point in the movie because of this type of crazy maneuver that they have to complete in order to hit the target. I love this GIF. You got to look it up. GIF. There. I love this because when animated, it actually does the whole flying over. I don't think anything is dropped, but you get the idea with this F-18. So if we had access to Pete's system, we pulled his search index. I'm actually going to go with the windows.edb since it's a Windows 10 machine. There is an opportunity to make use of that protocol handler. Well, okay, the search indexer made use of that protocol handler and walked the contents of all of the MSGs, all of the little Outlook files that Pete may have saved to his machine. And, PSTs, we got that down pat too, because Microsoft provides that protocol handler to access and go ahead and crawl through PST, so shared folders. So my thought is that if we had access to the windows.edb, we may come across like an auto summary of one of his saved Outlook messages. And he's talking to Iceman and says, this is an auto summary, people. You saw how much of the information from that .h file was saved in the auto summary. We could very well figure out that there was no need to create such a dangerous approach path. That's what I'm saying. So here it is, criminal investigation. Nay, I say maybe just an employee investigation. You're kicking back. You're like, maybe the file's not present on the file system. Used to be, no longer is. Let's take a look and see what we can derive. We can rip out of that windows.db, windows.edb, see if we can uncover anything that's incredibly valuable like that. Yeah. But I've always been fascinated because we have this incredible, easy to access, let's say easy to access, database that maps out the entire contents of the user's profiles. It becomes a central repository, not only for the user experience, but for adversaries. I mean, clearly this is already being done because we have third-party applications that can easily make access, make calls to, and dig information out of this windows.db. So I consider those Windows search as an attack surface, and I'm not the only one. This is so cool. The Windows search index has, in fact, been cited as earlier versions, Windows 10, but phantom DLLs. So phantom DLLs can be usurped because it's like, hey, this DLL that's loading in the context of this process, this DLL loading in the context of this process, makes a call to load a DLL that does not exist. So if an adversary is in the know about this, she can set up this masterful plan. I will be that DLL that is being called by msfte.dll. I will be the mstracer.dll. You get it. So we have that kind of fraught with danger. And then, of course, we lived through the search nightmare. The 0 day that was identified in Windows Search Protocol Handler, that would be the MS search. Yeah, you can actually craft a weaponized Word doc, specially crafted weaponized Word doc that will allow, I mean, the user is going to be like, hey, are you sure you want to do this? There's always going to be a prompt, right? But if the user clicks on a URL that is an MS search URL, and they say, go for it, there is an opportunity that remote malware can be downloaded, executed, simply based on the presence of a URL. So it's kind of cool. And it was this researcher, Matthew Hickey, that changed this, the MS search protocol handler vulnerability, to the other vulnerability with the OLE object. So created a full attack path. This was given a CVE, but this is 2023. There you go. So more on that, more on the ability to evade mark of the web, leading to code execution on the victim system. So, man, it's all kinds of bad things you can do. So what should you remember from this presentation? Well, number one, everything is interesting, but that's my crutch phrase. But the big heavy hitter points here, we have a default scope for what the search indexer is going after, is making a crawl through. And so you can change that, make it, augment that, shrink it down. There are different file types that can be introduced, can be registered for this indexing inclusion. And their metadata is specific to the iFilter that's designed to pull out the details and then put them into the property store table. Location remains the same across Windows 10, Windows 11. Remember, program data. And we got the names of the databases that you're going to find on each version of Windows. Shout out to my tool developers. We talked about some really good tools. Cider is going to be the one that's Windows 10, Windows 11, I can do it all. And got to consider, and I'm starting to think that maybe there should be a catch that kind of stops the search indexing service when you're in the midst of triage or when you decide to contain a machine. Yeah, and you're about to start investigating because of that volatile nature of the syncs that are transpiring to the windows.db at interval, and you don't really have visibility into, okay, when are those entries going to be deleted? When are those entries going to be added? So I want to have some control over that. And so that's my opportunity, like consider the volatility and how highly changeable this is. And that leaves 1 minute left for questions. 1 minute left for questions. There's your URLs for more details. Zach, what do you think? Did we learn something together?
And everybody in the chat just we're saying like how engaging you were and just like how enjoyable like your whole presentation was, and I agree. Like the whole time it's like, wow, you got me hooked, and like I genuinely have no idea what the heck you were talking about because I feel like all of that was just way past everything that I know. But I was still, I was able to kind of understand. And at the end, I feel like now, then at that point, I was like, okay, now I see how all of this pieces together. So it was awesome.
Thank you. Thank you very much for attending. I appreciate it. We do talk about the search index in my class that's in the Antisyphon catalog, and that's advanced endpoint investigations. Not mentioned until these last 5 seconds that we're sharing together. Good times. I think we're running it in April. So if you're interested in learning more.
Yeah, absolutely. Definitely check out her class if you guys haven't yet, for sure. It's on antisyphon.com. You guys can find it there. We can probably get a URL in the chat in a minute, hopefully. You have a couple of minutes to answer questions, or are you on a tight time crunch?
No, there are 18 questions. No, maybe it's just people saying, positive things. So I see them. Marlon, I have taught at USCC. That is, if you're new to the industry and you haven't checked out the US Cyber Challenges, USCC puts them on. Cyber Challenges, they're called Cyber Quests. You can take the little test, and if you do well enough, they'll invite you to a free camp, the USCC summer camps. Check it out. Somebody needs to drop a link to the USCC Cyber Quest challenges. I've done them for the last couple of years just because they're cool. Like, I think the last one was, oh, dude, ICS PCAP. And I was invited to attend, but I have taught there. If I can do network stuff, so can you. Looking. Do you see any other questions, Zach?
Yeah, there's a couple that I have queued up here, but I was grabbing that link. Oh, it looks like somebody already have it.
Awesome.
Let's see. Looking over here on my other screen, sorry. Can you do Windows indexing on a remote PC, or is this only on the local PC? That's from Lionshare.
Yes, so it's the whole network share, mapped network drive, and you have to include it. So not by default, but if you have a mapped share, then you can then include it and it will be indexing. And I noticed that that our OneDrive is part of the index, that's the GPO enterprise indexing scope. Yeah.
Somebody asked if an admin can index OneDrive.
Oh yeah, I'm glad someone asked. It's going on real time.
Charles asked if if I were to SSH into a machine, is there a command line method to access the search index?
Yeah, I know that PowerShell makes fast work of pulling stuff out of this database. And there are scripts out there. Oh, actually, I was looking at a script that was written in like 2010. Whoa, okay, we've been doing this for a while, but absolutely via PowerShell. And if you're SSHing to a machine, you should have the ability to, kick something off. But I don't know if anyone knows of an EDR out there that's engaging with the search index at this point. I think I've used almost all of those, say, Gartner Quadrant EDRs, and I haven't seen any that are like engaging it or even including it in a triage package at this point. That's not custom. So if anyone knows of it.
Can't Iyer could ask, is there a way to prevent Microsoft Edge from tracking local file access?
Oh, not that I know of. Ooh, geez, people are like, I don't use that. That's been the history of local file access. I don't use that at all. It's not going to have anything in there for me. It's as evidenced by what I just saw. I didn't think I was using Edge either, but it still populates with some of those local file accesses. Don't know if anything's changed in that regard for Windows 11. So I'd have to go look through my parse data sets.
And those are all your screenshots that you took probably like today, right?
Yes.
So what dual core song lyrics were you searching for?
Yeah, what is this? All the things. Come on, all the things. The song.
Yeah, the song. Okay. I said that was my question because I saw it on there. I was like, oh, I wonder what song she was searching for. Thank you. Tiger asked, does the EDB track fileless attacks, perhaps through some connection internet calls?
Oh my gosh. I think that could be a way to expand this research because that is so cool. Yeah, I didn't see any phantom entries, and I guess that's a good thing. Like there wasn't anything in there that I was not responsible for. But I don't know, in what regard things are triggered.
Does it rack your brain now? You're like, I have to look into that a little bit more now, or
Absolutely. I have some test cases. I can try it out. Mm-hmm. Yeah,
That's
thanks
awesome.
so much. Falcon, I see that you attended. And nothing wrong with that tool. So I don't have any, feature requests or issues, tickets to submit, but yeah, thank you so much for attending.
One other question. Have you ever investigated performing similar actions using Spotlight on Mac OS?
Yeah, one day I want to be a Mac expert, but no. There's some really good books behind me on Mac. That's what I have to say. But yeah, great documentation out there from researchers who are well versed in that space. I'd encourage you to look around on the Spotlight front.
Awesome. Thank you. That looks like all the questions that I had queued up. I don't think that I missed any, but if I did, I apologize.
Dude, I see someone Nidal is actually asking about everything from Void Tools. And I have to say, it's like the other search index or the other crawler, that has a big old CVE associated with it. I think it probably came out in the last year. So I gotta run back into my environment and see whether anyone's using everything.exe. But yeah, I mean, if you're using it, make sure you're using a patched version. Thanks for letting me answer that last one.
Here, I'll give you one more. Is there any traces in Windows logs if bad actors delete or edit Windows .edb files?
Ooh, and it would be recreated straight away. It's locked, so it would be pretty hard to delete. It's one of those files. Yeah, I don't know whether there'd be any errors. So I'll check it out. That sounds just terrible. I wonder if you turned off indexing, if it would destroy the backend DB. Probably not. Thank you for these excellent questions.